All right, let's move on to C, and we are doing number of atoms. So it says write the number of oxygen atoms found in each substance. Okay, so I'm going to look. Here is oxygen. Is there a subscript? No, there is not. Any parentheses? No, there is not. Is there a coefficient in front? No. What coefficient is assumed to be there? 1, which does not affect it at all. So this just has one singular oxygen. Let's look at this one. Here's the oxygen. Does it have a subscript? Yes, of 3. Are there parentheses? No. Is there a coefficient in front? No. So what coefficient is assumed to be there? 1, which doesn't affect the math or make it complicated. So this just has 3 oxygen atoms. Let's look at the next one. Here is oxygen. Okay. Is there a subscript? Yes, 3. Are there parentheses? Yes. Is the oxygen inside the parentheses? It sure is. And there's a subscript of 2 outside. So what does that mean? This 2 gets distributed to everything inside. Okay. So that means I have to multiply the 2 times N and 2 times O. Well, there were 3 O's inside times 2. So far I have 6 oxygens because 3 times 2. And then I'm going to check here. Are there any coefficients? No. So what coefficient is assumed to be there? A 1. That doesn't affect my math. I already determined I have 6. Okay. Let's check the next one. There's oxygen. Do I have a subscript? Yes, I do. It's 7. Do I have parentheses? Yes, I do. Is oxygen inside the parentheses? It sure is. Okay, so what do? I have to distribute. I have to multiply this 7 outside times everything that's inside the parentheses. So for oxygen, 7 times 7, which is 49. Then I look in front. Is there a coefficient? No, there is not. So what coefficient is assumed to be there? A 1. So multiply that by 1. It's the same thing, right? It doesn't affect my answer. I have 49 atoms of oxygen. All right, let's get to the next one. Here's oxygen. Is there a subscript? Yes. Are there parentheses? No. Is there a coefficient in front? Why, yes, there is. What do you do with a coefficient? Same thing you do with a subscript outside of the parentheses. You distribute the coefficient times each of the atoms, each of the elements you have atoms of. So 2 times 2 for hydrogen. What do I do for oxygen? 2 times 4. So that's 8. All right, let's look up here. Here's oxygen. Does it have a subscript? No. So that means I have 1, right? Are there parentheses? Yes. Is oxygen inside the parentheses? Yes, it is. So what does that mean? Remember, I have to distribute that 2, right? So for oxygen, I had 1, but I have to multiply it by the 2 outside the parentheses. So far, I have 2 atoms of oxygen. But look, there's a coefficient. So remember, the coefficient, I also have to distribute it. So now I have to take this 2 times 6, which gives me 12. All right, ready? Let's look at this one. Here's oxygen. Is there a subscript? Yes, there is. 4. So far, I have 4 atoms of oxygen. Are there parentheses? No, there are not. But look, I have a coefficient. So what do I have to do? Distribute 5 times 4. 20. 20 atoms of oxygen. All right, this one, here is my oxygen, right? Is there a subscript? No. Is there parentheses? No. Is there a coefficient? Yes. Only right here, right? This coefficient is just in front of this part, but that's where the oxygen is. So I have to distribute it. So remember, I just had no subscript, so I had 1 times 6. Okay, that's 6. All right, right here, these last two are the most complicated ones that you have to figure out. All right, because look at this. I have oxygen here and oxygen here. So let's do this oxygen first right here. Yes, there's a subscript of 3. Okay. Yes, there are parentheses, and yes, the oxygen is inside the parentheses. So far that gets me 3 times 2, which is 6, right? But I also have a coefficient, and that coefficient means I have to multiply that. So I have to take 6 times 2, and that gives me 12. But that's only this oxygen. I got another oxygen over here. Oh, goodness. Okay, so let's look at this oxygen. Well, no subscript, no parentheses. So I have to multiply it by this coefficient. So I do 1 times 4. Okay, so that gives me 4. Oops. But this coefficient in front right here affects the whole thing. So now I have to take this 4 times 2. That gives me 8. So I had 12 plus another 8. That's 20. Phew. All right, let's try this last one. Again, I've got 2 of them. So let's do this oxygen first. So I have a subscript, it's 4. No parentheses. Yes, coefficient, 4 times 3. So that's how many oxygens are right here. But now I have to do this oxygen. So the subscript is 1, no parentheses, times this coefficient is 10. But then this coefficient right here also applies because it's 3 of the whole thing. So then I got to do 10 times 3, which is 30. And then I have to do 12, which was in the first set, and 30, which is 42. And that is how you determine the number of atoms. Okay, conservation of mass. Answer the question, write the number of grams on the line. All right, so from the decomposition of water. So what does that mean? Okay, so that means I take water and I break it apart into its component elements. So hydrogen and oxygen. And I don't have to worry about balancing at this point. A student collects 28.0 grams of hydrogen. So 28.0 grams of hydrogen and 224 grams of oxygen. How much water was originally involved in the process? Well, what the conservation of mass says is that the mass of the products must equal the mass of the reactants. So I add these two together. 20, oops, I want that decimal point. 28 plus 224 equals 252. 252 on the product side, 252 on the reactant side. 252. A 10-gram sample of iron reacts with oxygen to form 18.2 grams of ferric oxide. So you don't even really need to know the formula, but it's something with iron and oxygen together. I'm just going to leave it just like that, okay? So 10 grams of iron reacts with oxygen, something, to form 18.2 grams of this. So how do I find this? Well, I know that 10 grams plus this equals 18.2. So if I just use this like an equation, I subtract 10, that will tell me how many grams of oxygen. So, I mean, you should know that, but if we just did it, 18.2 minus 10, 8.2. So we needed 8.2 grams of oxygen. All right, hydrogen and oxygen react chemically to form water, and here the formula is written. How much water would form if 14.8 grams of hydrogen reacted with 34.8 grams of oxygen? Remember, mass of the reactants has to equal the mass of the products. So I find the mass of the reactants by adding those two together. So I do 14.8 plus 34.8 equals. So I have 49.6 grams over here. So that side also has to have 49.6. All right, one more of these. When ammonium nitrate explodes, the products are nitrogen, oxygen, and water. So I have, oh, and here's the formula. So I don't even have to write it. Okay, so let's just erase this guy. Okay, let's go back here. When 40 grams of ammonium nitrate explodes, so you can see I have the whole reactant side here. I get 14 of nitrogen, 8 of oxygen. How much water? Okay, so plus, let's erase this because it's messy. Okay, this is a plus. All right, so first I'm going to add these two together, 14 plus 8. So if you don't know it, it's always okay to check it on the calendar, on the calculator, and not make mistakes. So 40 equals 22 plus whatever oxygen is. How do I solve for it? Minus 22 minus 22. So I do 40 minus 22, oops, equals 18. So 18 is how many grams of oxygen I needed. So again, the important thing you need to know for conservation of mass is that the mass of the reactants equals the mass of the products. So you're going to have a question where you're missing either one reactant or one product, and you're just going to solve a simple algebraic expression. And that's it. All right, this next section, we are deciding if it's balanced and writing yes or no. Okay, so you can see that the elements I'm looking at are N and H. So here's the reactant side, here's the product side. How many nitrogens on this side? 2. How many nitrogens on this side? 2 from the coefficient times 1. So that's 2. How many hydrogens? 3 times 2, 6. How many hydrogens on this side? 2 times 3, which is 6. So this, yes, this one is balanced. All right, let's look at this one. This is, again, nitrogen and hydrogen, nitrogen and hydrogen. How many nitrogen on this side? 2. On this side, 2 times 2 is 4 hydrogen. On this side, how many nitrogen? 3 times 1, which is 3. How many hydrogens? 3 times 3, which is 9. No, this is not balanced. All right, what about the next one? Well, I have nitrogen and hydrogen, nitrogen and hydrogen. How many do I have on this side? 2. And 2 hydrogens. On the other side, I have 1 nitrogen and 3 hydrogens. So no, 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 that is not balanced. Okay, so let's look at this one. Let's just go element by element. 1 zinc, 1 zinc. Check, balanced. For hydrogen, 2 times 1, so I have 2 hydrogen. On this side, I have 2 hydrogen. Check, it's balanced. Chlorine, I have 2 times 1, which is 2 chlorine. And on this side, I have 2 chlorine. Check. Well, that was everything. So yes, this one is balanced. Let's look here. So how many hydrogens? Well, here's where it's complicated and you have to be careful. So I'm going to actually save the hydrogen for last. What I'm going to do first is, do you see I have SO4 as a whole chunk? And then I have SO4 as a whole chunk here. All right, so how many SO4s on this side? 1. How many SO4s on this side? 1. So that's balanced. I'm going to just count it as a chunk, okay? Then I'm going to look, Na, how many do I have here? 1. But here, I have 2 NAs. As soon as I see something that's wrong, no, this absolutely is not balanced. What did I want to remind you about the hydrogens? Look, I have hydrogen here and hydrogen here. So I have to be careful when I'm adding it on this side, okay? All right, and last, let's look. How many nitrogens here? Sodiums. Sorry, how many sodiums here? 1. How many sodiums here? 2. Well, as soon as something is wrong, I can say no. That's it. Absolutely is not balanced. And there you go. That's just how you check to see if it's balanced.